Today we're going to talk about exponents. What you see in front of you, if you look over in the upper left corner, I wrote some examples of some exponents. An exponent has two parts. It has a base, that's the 3 here, and it has an exponent, which is the 2. So every exponent has two parts, a base, and then a number above it, and that's called the exponent. So if you notice the pattern here, 3 squared is the same as 3 times 3, which is 9. 3 to the third power is 3 times itself 3 times. 3 times 3 times 3. There's 3 3's here. So 3 to the third power really means 3 times 3 times 3, which is 27. Exponents are a way for mathematicians to write really big numbers quickly and to avoid having to write them out in a long multiplication problem. So it's kind of shorthand for multiplication. 3 to the fourth, you see that, notice that I have 4 3's here. So I hope that you're starting to see a pattern. 3 to the fifth is the same as 1, 2, 3, 4, 5. 3 times 3 times 3 times 3 times 3. There's 5 of those. And then we can also use exponents with variables. X to the third is 3 x's multiplied by each other. Now, we talked at the very beginning of the year about the importance of memorizing certain exponents, and I'm going to talk about this again on Tuesday, and I'll write the whole list on Tuesday. I didn't have a lot of room today. But some of the numbers that you really need to start memorizing for exponents is 2 squared, which is 4, 3 squared, 4 squared, and so forth. All the way down, if you can get down to 15 squared, that is probably your best bet. So don't just stop at 9 squared. Remember, memorize 10 squared, 11 squared, all the way to 15 squared. It's also a really good idea and helpful if you memorize 2 to the third power, 3 to the third power, and 4 to the third power. Later on, that list is going to get a little bit longer, but for now, start working on memorizing these for me. Now, we have some rules about exponents that you need to know. The first one is very important, and that is that whenever you have 1 for the exponent, remember mathematicians are lazy and they only write 1s and 0s if they have to. So x to the first power is typically written simply x. Remember that if you see a variable with no exponent above it, there really is one there. It's just 1. The next rule seems pretty counterintuitive, and I'll explain and prove why this is true when we get together on Tuesday. But for now, just memorize for me. X to the 0 power is 1. I don't care if it's 6,789 to the 0 power. Any number to the 0 power is just 1. And we'll explain why when I get back to class on Tuesday. When you want to add two numbers or two variables that have exponents, the only way that you can add them is if the exponents are the same. Notice that this is a, and that the bases are the same, x and x. So when you want to add two numbers or variables that have exponents, they have to be like terms. So x to the a plus x to the a is 2x to the a. When you're multiplying exponents, this rule is very handy. I'll show you the rule first, and then I'll give you some examples which will make it a lot clearer. X to the a power times x to the b power is the same as saying x to the a plus b. You add the two exponents together and you leave the base the same. Here's an example. 2 to the third power multiplied by 2 to the third power is the same as saying 2 to the 7th power. 3 plus 4 is 7. Notice that the base stays the same and you add the exponents. Here's another example. 3 to the first power. multiplied by 3 to the 5th power is the same as 3 to the 1 plus 5, which is 3 to the 6th power. Now, when you're doing your math problems, if you want to just add in your head the two exponents, that's fine. If you feel like it's safer to make that intermediate step, like I did on this problem, that is also fine. You can write it either way. Next rule is about dividing. Here I've written x to the a power divided by x to the b power. That is the same as x to the a minus b. And I think the examples will help you make sense of this. For example, 3 to the 5th power divided by 3 to the 2nd power is 3 to the 3rd. Notice that 5 minus 2 is 3. Another example is 4 to the 7th power divided by 4 to the 2nd power. That's the same as 4 to the 7th minus 2, which is 4 to the 5th power. And here's an example using variables. X to the 3rd power divided by x to the 1st power is equal to x to the 2nd. 3 minus 1 is 2. Now keep in mind that since mathematicians don't always write, a 1, that this would be the same as saying a to the 9 minus 1. There is a 1 there, it's just the mathematicians are lazy and don't write that. So this would be a to the 8th power. In your book, one of the examples or one of the problems in the book is x to the 3a divided by x to the 2a. And in this example, let me try and make that a look a little more like an a. We have x to the 3a minus 2a, which is equal to x to the 3a minus 2a is just a. Another problem that you're going to have to do this week is multiply more than one exponent or number with an exponent. For example, if you have z to the 3rd times z to the 2nd times z to the 7th, well, that is the same as saying z to the 3 plus 2 plus 7, which is z to the 12th